Hey everyone, welcome back to Learn with Washington YouTube channel and in this course we are going to learn about advanced Python programming for both professional and for beginners, and we are going to start right away by looking at list as one of the data structures in Python. So what is list? So list is a collection data type which is ordered and mutable. So it is immutable. Unlike sets, lists allow duplicate elements. So they are useful for preserving sequence of data and further iterating over it, meaning you can loop over a list. So lists are created with square brackets, as we can see. So we have our variable called list1 equals to, and then we have square braces. So the data types, there are bananas, that is a string, so we wrap it with a double quotes. So list takes various data types, not only string but even integers, and we are going to see that in a moment. So after defining our list and having the values, now we can print the list by saying print the variable name list1. So when we run the cell, we should be able to display all the elements we have within our list. So let's run the cell. You can see now our list values are printed down there. So let's do write some more codes to explain about list. So let's now have a code to elaborate a list that is taking different data types, and like the first one, list one, where we had all the string values. So let's have it as list2. So list2 equals to square braces, we have integers. So in that list we have integer, boolean and the string. So when you print list2, you should be able to display the list. So let's run the cell. So you can see the list values are printed. So that's all about list, how we display list, and lists are mutable. So that's one of the things that makes it special. And it takes list takes duplicate elements, meaning you can have bananas and have bananas again. So let's demonstrate that by writing a code with list having duplicate elements. So let's now have list3 and then have duplicate values within it, and then we print it. So let's have 1 1 2 4 7, and then we print the list. So when we run the cell, we should be able to display all the duplicates. As you can see, each duplicate is printed and treated as an element of its own. So let's go to another thing, that is accessing elements within a list. So let's say you have a list consisting of a number of elements and you want to access a specific element within that list. So we will introduce indexing to access that, and we are going to demonstrate that using a code. So let's add the cell. So let's copy the list we already defined. So let's have it as item 1. That is the item we want to access from a specific list. So item 1 equals to, we are getting it from list 1, so we have list 1 and then we have the index. No, we don't have to give it a variable name, we just have to write list 1 and then we specify the index value of the element we want to access. So that one will give us an error. So in list you don't have to when you want to access the variable from a list, you just write the list name and you have the index value towards the end. So I just wanted to demonstrate for you that this is one of the mistakes, and this don't work really in list. So the correct code we are going to write, so as you can see, when you have item 1 equals to list 3 and the first index, when we print item 1 we get the first value in it. So let's try one more time by accessing a different element. You can see now we have bananas for item list 1. What we have in at the very first index there is banana. So this is how you can access elements within a list. So let's try again and access another element. So let's have item 2 is equals to list 1 and we specify the index value. So indexing starts from 0. So the first element in a list, that is, it is at index 0. So when we say index negative 1, that is the very last element within a list. So this is now list slicing. We are accessing an element that is the last element within a list. We use index list. Indexing is -1, so a value that is at index -1, that is the last value in the list. I hope you are mastering that. So when you want to access the very last thing, the very last element in a list, you print the index that is at, you print the element that is at index -1. So let's add one more cell to demonstrate how you can access list values. So that is when you want to add, as we said, lists are mutable, meaning you can have a list and then add some more elements within it. So item 3, we use the method append. Append means adding an element at the very end of the list. You are appending some values, adding some values towards the end. So that one will use list1.append. So we are using the .append method. But one more thing that we need to highlight here is that you can only append one value at a time. So when you append more values as what we are trying to do here, this is not going to work. So this is just a demonstration that when you try this, you're going to get a type error. As you can see, append text list.append takes exactly one argument, but for us we have given 5, so we are going to remove some. You can only append one value at a time. So when we run the cell, we are trying to append, or let's see what is happening. So list1.append, and then we just print list1. Yeah, so this is what I was saying. You don't have to assign a variable name. You just have list1.append. You just append a value and then you execute. As you can see now, this one works. So you can only append one element at a time, and when appending an element in a list, you don't have to assign another variable name. You just say list.append list.sort. So sort is another one that sorts the value. Let's say in this case, if we had the previous one, we appended Nairobi, and as you can see now, Nairobi is not the last element, so we have sorted it. So as we list1.sort, when we say reverse, now you reverse the list in the appearance. So these are some of the methods that we use in list to modify it. So I hope you understand these methods and how you are going through. So as for this case, we have only demonstrated 3 methods, but there are more methods than that. So let's say you want to loop over a list, so that is iterating over a list. Let's see how we can do that. So we are going to have for I. So if in case you didn't master the Python basics, make sure you go to our course where we are demonstrating the loops, so that you understand this. So for I in list1, print I. So we are printing all the values in a list. That is now iterating over a list, or looping over the list. So let's see how we can have a statement within our list. So for example, if apple, a string value, if apple in list1, we are going to say something, print. So we are seeing how we can play around with our list data type. So if apple in list, print yes, else. So as you can see, this is advanced course, but we are revisiting what we did in our Python basic course, which I'll give the link in the description, and ensure you go through it so that you have a good grasp of this. So if apple in list1, print yes, else, we are going to print no. So you can see now in our list we have an element apple. So if we have, let's say we have another thing that don't exist within our list, so this is now having a statement within the list. So you can always do a lot of stuff with the list that you love. So let's say if dog in list, print yourselves no. So you can see now we have no. So that's exactly what it is when it comes to list. So let's go to slicing list. So what do we mean by slicing a list? Slicing a list means just taking a particular portion of it. You don't want to print all of it, or you don't want to work with everything in the list, but just working with a particular portion. So let's say we have our list A and some values, but we want to print values from the very first index up to the fourth index. So we are saying for 0 to 5. So it will end at 4. If we make it 3 to 8, it means we are printing element from index 8 up to the 7th element. So as you can see, we have that. So we are slicing a list, just printing for a portion of the list. That is what we meant by list slicing. So let's go to list comprehension. So let's have a list AB. So AB is equals to I times I, for example, that is I squared, for, so this is like a professional code. There is a way you can write this. We demonstrated all these tricks, Python tricks, in our Python basics course. So AB is equals to list of I squared for I in A. So if we print AB, then we'll square all the values in the list. You can see how it works. So that is now an example of list comprehension. So we are going to a different thing, that is tuples in Python. So what is it? So tuple is a collection of objects which is ordered and immutable. So you have to know that tuples are immutable, unlike list. These ones you can never immute, you can never modify them. They are similar to list. The main difference is the immutability. So in list we are using the brackets, round brackets, and comma separated values. So let's dive into it and demonstrate this using codes. So it is important to mention that the methods that we used in list, we can really use them even in tuples. The methods work the same. So let's have our variable tuple1. We have orange. So it is just the same as what we did in list, just that this one we are using round brackets, and of course there we can't modify them. They are immutable. It is also taking different data types, just like in list. As you can see in our tuple, we have string, integers, boolean. So print tuple1. So we have the output there. It works exactly as it did in list. So let's go to another cell and demonstrate something. So let's try to slice our tuple elements by printing the first value up to a value in the third index. So even if we try to slice it, we are still getting the same output that I was trying to demonstrate, that list tuples are immutable, so you can never remove some part and have some part. You can see we are trying to slice it like what we did in list, but we are not able to really slice it. So this is, I wanted to show it by code that tuples are really immutable. But what if we assign it to a variable and we say that tuple 2 is equals to tuple 1, but we get the elements, specific elements, and then let's see. So we can never modify a tuple 1, but we can have another tuple with the values. So you can see what we did at first is we were trying to slice it, but we were not able to do so. But if we assign another variable and we have another tuple and we give it the values of another tuple, then it works. So let's go to another thing, that is dictionaries in Python. So dictionary is a collection which is unordered, changeable, and indexed. A dictionary consists of a collection of key value pairs. Each key value pair maps the key to its associated value. A dictionary is written in braces. Each key is separated from its value by a colon, and the items are separated by commas. That is a theoretical explanation of what dictionaries are in Python. So let's dive into code and we explain this by code. So let's have our very first dictionary. So that is dictionary 1. We have the braces, and then we have our first value. Our first key value there, name, we have the colon, and then we have its value, Washington, and then so we are defining our dictionary, the elements within our dictionary. So we have the name, Washington, hobby, let's have it as programming, and then age, let's have an age there. So we must always enclose the key with a double quote. So we are going to explain now another way that we can represent dictionaries. So this is one of the way of doing it. Oops, we don't have the semicolon. So semicolon. So let's print. So we should get our, if we print our dictionary, we should get the values. So dictionary can store as many values as possible. As many values as possible. As you can see, we have the dictionary elements displayed. So another thing to represent, another way to represent dictionaries is by using the dictionary method, dict method. So instead of having so this is also another simple and clear way to represent our dictionaries. Let's have it as dictionary 2 equals to dictionary. So this one, we are the key, we are not enclosing the key with the double quotes. We just have it as that, and then we have the equal sign to assign it its value. So when we execute that, you can see we have the same thing there. So that is another way of representing dictionaries. So let's have dictionary 3. You are using the dictionary method. Name equals learn with Washington. Then request equals subscribe. Then now let's print dictionary 3. So I hope now you got the concept of dictionaries and how you can represent them in 2 different ways. You can see we have the output is just the same. So in our next thing we are going to look at iterators. So iterators module is a collection of tools for handling iterators. So simply put, iterators are data types that can be used in a for loop. Don't mind the text. The most common iterator in Python is the list. So let's demonstrate what iterators are really fast. So we are going to import the module. So it is a module. So from iterators, for example, let's import permutation. So this one is really useful in math. You can perform permutation in some values really fast using Python. So let's have a variable there, permutation 1 equals to permutation. So we use the permutations method because we already imported permutations from iterators. We have the values there. So if we run this cell, our output should be all those values, the permutation of those values that we have in there. So we are converting the values into a list first, and then we perform the permutation. So you can see the values can be permuted for multiple times. So that was all about permutation. So let's continue with the permutation. Do one more example. So let's perform one more thing here to explain what we can do with iterators. So from iterators we are now importing product. So the other time we imported permutations, this time we can import a product. So we have let's have a variable product1 to be equals to product. So this one's performed multiplies some elements in a list. So we can have row 1, that is list 1, and then we have list 2. So we are going to multiply. This is more of matrix multiplication. So if we print product 1, so we first convert it into list the same way we did with permutations. Then we print it. So we should get the multiplication. We should multiply the two lists. So there we have. So as you can see, we have one by one is we have 1 that is 1 from the first list and the second list, and then we have 1 4 3 1 3 4. I hope you understand how that multiplication works. It really works the same as that of matrix. So let's continue. So next thing, let's dive into another thing now, that is lambda function. We could have learned this in our basic Python course, but let's learn it at this point because you want to do a lot of things using lambda function. So this is a small one-line anonymous function that is defined without a name. So it is a function without a name. It sounds funny, but it's. So let's demonstrate this. So the syntax there is that you have the lambda, you start with the lambda keyword, you go to argument, you have the colon there, and then you have your expression. So that is the simple syntax. It's as simple as that. So let's have lambda. Let's follow the syntax there. So we have lambda, let's have our argument as x colon, and then expression is x squared. So we assign it a variable there. So lam1 is equals to lambda, the argument is x and the expression is x squared. So when we have the variable name, when we pass in the argument there as 10, you can see we are getting 10 times 10, that is 100. So let's do one more thing. So the argument there is iterable, so we don't have to define it anywhere. N. So let's have lam2 is equals to lambda function that multiplies n by 10. So when we have lam2, when we call it and we pass in the value there as 100, for example, so if we run the cell, we should get 1000. So you can see how simple lambda function is. So it is just anonymous and it is one line. It has no name and you write it in a single line, and it performs exactly what you want it to perform there. So that's all about lambda function. I know now you understand what it means. So we are going into another thing, one more serious thing, that is exceptions and error handling in Python. This is one of the serious concepts that you must master to be a Python programmer. So we are going to handle an exception. So one of the exception is like div. You're trying to divide a value by 0. So this is one of the most commonly used one. So let's try dividing a value by 0. So try that, and then we are going to accept. Print, in case of an error, print no zero division. So we are performing an exception. We are trying to divide some number, but if it is not, if we try to divide it by 0, then we are getting an error message there. No zero division in math. So that we are trying to handle an error. So So let's catch now. That was try. We try to divide it by 0 and then we are printing an error message. So next thing here, this is also works the same, but we are going to catch an exception. So should have it there as E. What is happening here? So the word catch there is wrong. We are having a wrong syntax, so let's correct it. So we should have the word there except. So try dividing our value by 0, and then we are accepting, we are catching an exception. So accept exception as E, print E. So this one is going to print as the type of the error there. Division by 0. So that means now we are getting an error. So we are catching the error and then we display it. So these are two ways of handling exceptions in Python. Let's demonstrate one more time so that you grasp it, because this is a very important area in coding. So let's try to divide. So let's include some if else statement here. So try dividing a value by 10 and then we catch an exception as E. So if there is an error, we are going to print the error, else we are what do we say something? Except exception as E, print, else print everything is fine. That one is if there is no error. We are going to display the text everything is fine. As you can see now, we are getting the message everything is fine. So if we make it to be 0, the message will be different now. Division by 0. So that's all about try and catch in Python. So let's go to another area in Python, that is random module. So let's demonstrate about random. So random also has, random is a inbuilt Python module. So first you need to import it. You need to import module first. So let's have it as import random. Then we have a variable there, number4 is equals to random dot random. So we are going to print, this one means the variable number4 is any random value. So Python will give any value there. So you can see we are getting a random value. So when we run again, we should get a very different value from that. can see now it is giving us random values, different random values. So let's do one or two more examples. So random, so you can, there are various methods to use here in random module. So like dot uniform, rand int, rand range. So we can't do all of them right now, but I'm introducing you how you can use them. So random dot uniform, we have a range there of 5 to 40. So when we run it, we're getting different random values in every execution. We can't get the same value twice. So let's try another method there. Random.rand range. Let's use rand range there. So we are getting random values, but within a specified range. That is between, let's have it as 1 and 10. So let's print it. Just after printing num1, let's print num7. As you can see, we have 1. Oh no, that one is not really necessary. So I want to print them in 2 different lines, but that is not really necessary. Let's just go on. Let's run the code again and to see. So you can see now we have a different random value of 8. So we are getting random values, but they are within the range of 1 and 10. So that is what rand range does. So let's go to another thing, that is decorators. So decorators is also a very serious concept. So decorator is a function that takes another function as an argument. So we have it is a function but takes another function as an argument and then modifies its behavior. So let's see how that one is happening. So we are going to define a function. So within the function there we have another function, the wrapper function. It seems there is an error. So let's rewrite it again. So this is now the function code. So we have a function called start and decorator that takes an argument func, and within it we have another function, that is the wrapper function. So the wrapper function print a statement there, start. So this, I'm just using this to explain it. So this is basic, so we'll see how we can do this again. So and then we were printing the argument func, and then we print again end, and then we are returning the function, return wrapper function. And then down there we have another function called print name, and it is printing a string line with Washington. And then we are calling the function print name and the print function there. So print name, so as you can see down there, print name takes the start and decorator function as an argument, and then we are passing in another function. We are calling it to itself. You can see that we are assigning a function to itself, So we are trying to extend its behavior. So we'll have the print name. So where we add the function, where we have the argument, we are now displaying the print name function. That is, so we are going to have what print name does is the output of the print name function is what we are going to have at that point. So that one it looks strange, but it's really easy to master if you go through the code. So let's see how we can do this using the at symbol. So in Python decorators, we use at symbol to show that it is a decorator, just like that. And then we have the function name. So when we have at certain decorator, that one means now we are modifying that function. So like previously, we wrapped the function and assign it to itself. So at this point, we are going to use an at operator to achieve that. So at start end operator, we are doing that to show that we are modifying the function there, start end decorator. So let's define another function down there, print. Let's call it my name. And it is displaying the text, subscribe to Learn with Washington. If you are enjoying the show, you will take your 1 second to subscribe and then we continue. That's what this function now says here. So, and remember, we are modifying what we have. We are modifying the functionality of start and decorate. So if we call the function, you can see now we are start and decorator. We are displaying the function. We are displaying the text. Subscribe to Learn with Washington. Because we are just modifying the behavior of the main function. That's really what it means. So you can apply decorators in various ways. So you can have a function and you call it. You can have a function that does specific thing and then you call it various times, but you are modifying its behavior depending on the task you want to achieve. So that's basically the application of decorators in Python. It's a really cool concept. So let's go to another concept in advanced Python programming, and that is generators. So let's have some text there. So it is not really decorators but generators. I'm sorry for that. So let's correct it. So generators, let's correct. So generators are functions that can be that can be paused and resumed on the fly. So they are returning an object that can be iterated over, and like list, they are slow or lazy. That means they produce one item at a time and only when asked. So one of the things that makes this unique is that we are using yield. Instead of return, we use yield statement in Python generator. So we are generating just from the name Python generators, we are generating a value, but one value at a time, but only when we are asked to generate it. But it is a function. Really important to remember that. I'm sure you are understanding this. So let's see how we are doing that. So we are using yield. instead of return. So let's have a code implementation of this. So define, as we said, it is a function, so we are just defining it normally the same way we defined, the same way we've been defining functions in Python. So let's write the code. It's very easy to understand in coding than reading the text. The text there, I'm just explaining what it does. So define generator, and it takes an argument 1. So while it takes an argument num, so while num is greater than 0, we yield num. So num minus equals to 0. So let's have the variable count1 is equals to generator 1, and then we pass in the value num there. So when we run the code, it works because it has no error, but there are more likelihood that we are going to run into an infinite loop, because it will just yield. We've said it to yield as much as num is greater than 0. So if we pass a value that is 0, if we pass any value that is greater than 0, then of course we'll be yielding a value infinitely. But let's prove that by just running the code there. Seems there is an error. So it should be for I in count1, sorry. Instead of generator 1, we are supposed to have count1 there. So if we run the cell, you can see we are yielding 10 is greater than 0, yes, but we are yielding a value 0 infinitely. So so let's see how this one works. So we have defined a function countdown which takes parameter num. We are print starting. So while num is greater than 0, yield num. So so this is what I was trying to do at that point, but we didn't get it right. So num, we are going to reduce num by 1. So for x in countdown, so cd there countdown. So we are yielding the value by 1 each and every time until now it is equals to 0, equals or less than 0. That's what it is. So thank you all. Happy coding. I hope you managed to grasp the concept.